Alright, now that you know how to do slicing and iterating through NumPy arrays, let's do some more specific operations. And that would be stocking NumPy arrays, so concatenating NumPy arrays to each other, and also splitting a NumPy array to smaller arrays. Yeah, I have this NumPy array still here, so let's start with stocking two NumPy arrays. To do that, you may want to create a new variable where you'll save your big array, and that would be equal to NumPy, and the method to stock two NumPy arrays. Actually, there are two methods. One is horizontal stack, so hstack. That expects from you to pass two or more NumPy arrays that you want to stack horizontally. So let me pass OMG and then the same array. It's not a problem. If you had two different arrays, you could do that, but I'm just passing the same array there. Now, if you execute this, you'll get an error, and I want you to see this error so that you understand it. So it says hstack takes one positional argument, but two were given, which means that hstack inside the brackets it gets only one argument, but we're passing two. So how do we go about concatenating two NumPy arrays? We can't just pass one NumPy array there. So the solution here is to have a tuple of NumPy arrays, just like that. So a tuple inside the input of the hstack method. You execute that, and here is a stacked array. Yeah, so this is the first array, and then the next array, which in this case happens to be the same one, but if you want, you can add more. And you get a longer array, which is not very good looking like that, so you can print that out. And yeah, now you see the difference. So the first array, the second, and the third one. And if you want to stack vertically, you'd want to do V there. And yeah, as you expected, this will concatenate the arrays in the vertical position, in the vertical axis. Be aware that if you try to concatenate arrays that have different dimensions, you'll get an error. So IMC has 3 dimensions, if you can remember that from up here. Now you'll learn how to concatenate and how about splitting an array into smaller arrays. Well, to do that, you could create a variable and then numpy dot horizontal split for splitting horizontally, and then this expects a numpy array and how many arrays you want to produce out of that. So horizontally, let's say 3. And yeah, this says array split does not result in an equal division. The reason to that is, this array has 1, 2, 3, 4, 5 columns. So you're trying to divide 5 by 3, and NumPy cannot decide how to do that. So should it give to you a NumPy array with these 2 columns first, and then another NumPy array with 2 columns, and then a last NumPy array with 1 column? So NumPy cannot do that. Yeah, what you should do is maybe 5 there, and LST. And that should give you 5 different NumPy arrays, which in this case happens to be, 1 array for each column. And you can do vertical splitting. This time we can try 3 because we have 9 rows there. And yeah, we get 3 small arrays. Note that this LST, so the split, what it produces is a Python list of NumPy arrays. So it's a plain Python list. And out of that you can access each of the NumPy arrays if you like. You know that. So it outputs the first array. And yeah, that's about concatenating and splitting NumPy arrays. Hope I gave you a good overview of NumPy. I tried to do some practical examples like opening images, but this is still yet in the theoretical part, so NumPy is quite theoretical, and you only understand it when you get to use like these real-world examples, like working with pandas as we did previously in the course, and also working with images. So we're going to do some hardcore image processing in the next lectures, in the next section, and you'll see how NumPy comes in handy in there. And yeah, I hope you enjoyed this, and I'll see you later.